Question 1. Risk assessment procedures indicate that a new LTE network deployment will utilize a combination of licensed and unlicensed frequency bands. Which of the following approaches best ensures compliance with regulatory requirements for spectrum usage and interference mitigation? Option A. Documenting all licensed and unlicensed spectrum bands to be used, understanding their specific regulatory conditions, and implementing appropriate interference mitigation techniques. Option B. Assuming that all available spectrum can be utilized as long as the network operates within its design capacity. Option C. Addressing interference issues only after receiving formal complaints from other spectrum users. Option D. Relying on the default equipment configurations provided by the vendor to meet all regulatory obligations. The correct answer is A. Documenting all licensed and unlicensed spectrum bands to be used, understanding their specific regulatory conditions, and implementing appropriate interference mitigation techniques. Explanation. Scenario analysis. This scenario presents a professional challenge related to ensuring compliance with regulatory requirements for LTE network deployment, specifically concerning spectrum usage and interference mitigation. The challenge lies in balancing the need for efficient network operation and service delivery with the absolute necessity of adhering to the regulatory framework established by the relevant authority. Failure to comply can result in significant penalties, service disruption, and damage to the service provider's reputation. Careful judgment is required to interpret and apply complex regulations to real-world network configurations. Correct approach analysis. The correct approach involves a proactive and systematic process of identifying and documenting all licensed and unlicensed spectrum bands that the LTE network will utilize. This includes understanding the specific power limits, emission masks, and operational restrictions associated with each band as defined by the regulatory body. Furthermore, it necessitates the implementation of robust interference detection and mitigation mechanisms, such as dynamic frequency selection, DFS, and transmit power control, TPC, to prevent harmful interference with other licensed services. This approach represents best professional practice because it directly addresses the core regulatory obligations of spectrum stewardship and interference avoidance, which are paramount for maintaining the integrity of the radio frequency environment and ensuring lawful operation of the LTE network. Adherence to these principles is a fundamental ethical and legal requirement for any telecommunications service provider. Incorrect approaches analysis. One incorrect approach is to assume that all available spectrum can be used without explicit regulatory approval or adherence to specific band conditions. This is a regulatory failure because it disregards the licensing framework and the potential for causing harmful interference to other users, which is a direct violation of spectrum management laws. Another incorrect approach is to rely solely on the default configurations of network equipment without verifying their compliance with local regulations. This is an ethical and professional failure as it abdicates responsibility for due diligence and assumes that equipment manufacturers have accounted for all jurisdictional requirements, which is not always the case. A third incorrect approach is to only address interference issues reactively after they have been reported. This is a failure in proactive risk management and regulatory compliance, as it allows for potential violations to occur before being rectified, leading to a higher likelihood of penalties and service degradation. Professional reasoning. Professionals in this field must adopt a risk-based approach to regulatory compliance. This involves 1. Thoroughly understanding the applicable regulatory framework for the specific jurisdiction. 2. Conducting a comprehensive audit of all planned spectrum usage and network configurations against these regulations. 3. Implementing technical solutions and operational procedures to ensure ongoing compliance. 4. Establishing monitoring and reporting mechanisms to detect and address any deviations promptly. 5. Maintaining detailed documentation of all compliance activities. This structured decision-making process ensures that network deployments are not only technically sound, but also legally and ethically responsible. Question 2. During the evaluation of a new LTE network deployment plan for a service provider operating within the United States, which of the following actions demonstrates the most robust adherence to regulatory compliance requirements concerning radio frequency spectrum usage and network operation? Option A. Deploying equipment that has been certified by a regulatory body in a different country, assuming similar technical specifications will satisfy U.S. requirements. Option B. Implementing the network using equipment that meets general international telecommunications standards without specifically confirming its compliance with US FCC regulations. Option C. Prioritizing the fastest possible network rollout by deferring detailed verification of specific frequency band allocations and power limitations until after initial service launch. Option D. Ensuring all deployed equipment has received FCC certification and that the network operates within the licensed frequency bands and power limits as defined by the FCC. The correct answer is D. Ensuring all deployed equipment has received FCC certification and that the network operates within the licensed frequency bands and power limits as defined by the FCC. Explanation: this scenario is professionally challenging because implementing LTE networks involves adhering to stringent regulatory frameworks that govern spectrum usage, network deployment, and data privacy. Service providers must balance technical implementation with legal compliance to avoid significant penalties and maintain public trust. Careful judgment is required to ensure all network operations align with the specified regulatory requirements for the jurisdiction. The correct approach represents best professional practice because it prioritizes adherence to the established regulatory framework for spectrum allocation and usage. In the context of implementing LTE networks, this means ensuring that the deployed network operates within the licensed frequency bands and complies with power limits and interference mitigation requirements set by the relevant regulatory body. This proactive compliance minimizes the risk of regulatory sanctions, ensures efficient spectrum utilization, and prevents disruption to other licensed services. An incorrect approach that involves deploying equipment without verifying its compliance with local regulatory standards is professionally unacceptable. This failure constitutes a direct violation of spectrum management regulations, potentially leading to interference with other licensed services and resulting in fines, equipment seizure, and operational shutdowns. Ethically, it demonstrates a disregard for the established legal framework, designed to ensure orderly and fair use of public resources like radio spectrum. Another incorrect approach, such as neglecting to implement data privacy measures mandated by the jurisdiction, is also professionally unacceptable. LTE networks handle sensitive user data, and failure to comply with data protection laws can lead to severe legal repercussions, reputational damage, and loss of customer confidence. This demonstrates a lack of due diligence in protecting user information, which is a fundamental ethical and legal obligation. A third incorrect approach, which is to assume that equipment certified in one jurisdiction is automatically compliant in another, is a critical professional failure. Regulatory requirements for radio frequency emissions, safety standards, and network operation vary significantly between jurisdictions. Failing to obtain local certification and adhere to local regulations can result in non-compliant equipment being deployed, leading to the same consequences as deploying uncertified equipment. The professional decision-making process for similar situations should involve a thorough understanding of the specific regulatory landscape of the target deployment jurisdiction. This includes consulting official regulatory documentation, engaging with legal and compliance experts, and ensuring that all network design, equipment selection, and operational procedures are vetted against these requirements before implementation. A risk-based approach, prioritizing compliance in all aspects of network deployment and operation, is essential. Question 3. Risk assessment procedures indicate that the introduction of new network functions within the LTE core network may involve new data processing activities and potentially impact lawful interception capabilities. Considering the regulatory framework for telecommunication service providers, which of the following actions is the most appropriate to ensure compliance? Option A. Conduct a comprehensive review of the proposed network changes against all applicable national telecommunications regulations, data protection laws, and lawful interception mandates to identify and address any compliance gaps before deployment. Option B. Implement the new network functions based on internal interpretations of regulatory requirements, without seeking external validation or formal legal review. Option C. Prioritize the technical performance and security of the new network functions, deferring any detailed regulatory compliance checks until after the network has been fully operational. Option D. Proceed with the deployment of the new network functions, assuming that existing compliance measures will adequately cover the new functionalities. Correct answer is A. Conduct a comprehensive review of the proposed network changes against all applicable national telecommunications regulations, data protection laws, and lawful interception mandates to identify and address any compliance gaps before deployment. Explanation. Scenario analysis. This scenario presents a professional challenge related to ensuring compliance with regulatory frameworks governing the deployment and operation of LTE networks within a service provider context. The challenge lies in balancing the technical requirements for network performance and security with the legal and ethical obligations to protect subscriber data and comply with national telecommunications regulations. Specifically, the introduction of new network functions and the potential for data processing across different geographical or administrative domains necessitates a thorough understanding of data privacy laws and lawful interception requirements. Failure to adequately address these aspects can lead to significant legal penalties, reputational damage, and loss of customer trust. Correct approach analysis. The correct approach involves a proactive and comprehensive review of the proposed network changes against the relevant regulatory framework. This includes identifying any new data processing activities, assessing their compliance with data protection laws, such as those pertaining to the collection, storage, and transfer of personal data, and ensuring that lawful interception capabilities are maintained and configured according to legal mandates. This approach demonstrates due diligence and a commitment to operating within the bounds of the law, which is a fundamental professional responsibility for any service provider. It ensures that the network's design and implementation are not only technically sound, but also legally compliant, thereby mitigating risks of regulatory noncompliance and associated penalties. Incorrect approaches analysis. Proceeding with the deployment without a thorough regulatory review is a significant ethical and regulatory failure. This approach prioritizes technical implementation over legal obligations, potentially leading to the inadvertent violation of data privacy laws or lawful interception mandates. Such a failure can result in severe legal repercussions, including fines and operational restrictions. Focusing solely on the technical performance metrics of the new network functions, while important, is insufficient from a regulatory compliance standpoint. This approach overlooks the critical legal and ethical considerations surrounding data handling and network surveillance, which are integral to operating a telecommunications service. It represents a narrow, technically driven perspective that neglects broader societal and legal responsibilities. Implementing the changes based on assumptions about regulatory compliance without explicit verification is also a flawed strategy. Assumptions can be incorrect, and the regulatory landscape is subject to change. This approach lacks the rigor required for ensuring compliance and exposes the organization to risks of noncompliance due to unverified assumptions. It fails to uphold the professional standard of ensuring that all operational activities are legally sound. Professional reasoning. Professionals in this field must adopt a risk-based approach to regulatory compliance. This involves identifying potential regulatory risks associated with any new technology or service deployment, assessing the likelihood and impact of these risks, and implementing appropriate mitigation strategies. A key part of this process is to consult relevant regulatory documentation, and where necessary, seek legal counsel to ensure a comprehensive understanding of obligations. Decision-making should prioritize adherence to the law and ethical principles, ensuring that technical advancements do not come at the expense of subscriber privacy or national security requirements. A continuous monitoring and review process is also essential to adapt to evolving regulatory landscapes. Question 4. Compliance review shows that a new LTE network deployment in the United States is planned to utilize spectrum in the 700 MHz band. The deployment team has proposed a configuration that aims for maximum spectral efficiency and coverage. However, there is a concern that the proposed out-of-band emissions from the base stations might exceed the limits specified by the Federal Communications Commission, FCC, for this band, potentially causing interference to adjacent licensed services. Which of the following actions is the most appropriate to ensure regulatory compliance? Option A. Focus on achieving the highest possible network performance metrics, such as throughput and latency, and address any potential interference issues only if complaints are received from other spectrum users. Option B. Rely on the equipment vendor's general compliance statements for the base station hardware, assuming that standard configurations will inherently meet FCC requirements. Option C. Implement advanced interference cancellation techniques within the network to mitigate any potential interference, without explicitly verifying the out-of-band emission levels against FCC limits. Option D. Conduct a detailed analysis of the proposed base station configurations, including power levels, antenna characteristics, and filtering, to verify that out-of-band emissions comply with FCC Part 27 regulations and relevant FCC measurement procedures. The correct answer is D. Conduct a detailed analysis of the proposed base station configurations, including power levels, antenna characteristics, and filtering, to verify that out-of-band emissions comply with FCC Part 27 regulations and relevant FCC measurement procedures. Explanation. This scenario presents a professional challenge in ensuring that a new LTE network deployment adheres to the specific regulatory requirements for spectrum usage and interference mitigation, as mandated by the relevant U.S. regulatory body, the Federal Communications Commission, FCC. The challenge lies in balancing the technical imperative to deploy a high-performance network with the legal obligation to prevent harmful interference to existing licensed services. Careful judgment is required to interpret and apply complex FCC rules, such as those found in Title 47 of the Code of Federal Regulations, CFR, particularly parts related to mobile services and interference. The correct approach involves a thorough review of the proposed network's technical parameters against FCC Part 27 rules, which govern the use of broadband spectrum, and Part 15 rules, which address unintentional radiators and potential interference. This includes verifying that the base station power levels, antenna gain, and out-of-band emissions are within the limits specified by the FCC for the licensed frequency bands. Furthermore, it necessitates confirming that the network's design incorporates appropriate interference mitigation techniques, such as coordinated frequency planning and intercell interference coordination, ISIC, to protect adjacent channels and other licensed users. This proactive and detailed technical validation against specific FCC regulations represents best professional practice because it directly addresses the legal and operational requirements for deploying a compliant LTE network, thereby minimizing the risk of regulatory penalties, service disruptions, and damage to the operator's reputation. An incorrect approach that focuses solely on achieving maximum network throughput without explicit verification against FCC emission limits would be professionally unacceptable. This failure would constitute a direct violation of FCC rules, potentially leading to significant fines and mandatory network modifications. Another incorrect approach that relies on general industry best practices for interference management without confirming adherence to specific FCC mandates would also be a regulatory failure. While industry best practices are valuable, they do not supersede explicit legal requirements. A third incorrect approach that assumes compliance based on the equipment vendor's general certifications without performing site-specific validation and analysis against the actual deployment parameters and FCC rules would be a critical oversight. Vendor certifications typically cover equipment design, not the specific operational environment and configuration, which are the responsibility of the deploying entity. Professionals should adopt a decision-making framework that prioritizes regulatory compliance from the initial design phase through to network operation. This involves 1. Identifying all applicable regulatory frameworks, in this case, FCC rules. 2. Thoroughly understanding the specific requirements within those frameworks related to spectrum usage, power limits, and interference. 3. Integrating compliance checks into the network design and deployment process. 4. Conducting rigorous testing and validation to confirm adherence to these requirements. 5. Maintaining detailed documentation of compliance efforts and any necessary mitigation strategies. Question 5. Regulatory review indicates that a service provider is implementing a new LTE core network. A key consideration for network deployment and operation is the ability to facilitate lawful intercept requests from authorized government agencies. Which of the following network design and configuration approaches best ensures compliance with relevant U.S. federal regulations concerning lawful intercept capabilities? Option A. Relying solely on standard network logging and troubleshooting tools to provide data to law enforcement when requested. Option B. Implementing lawful intercept capabilities only after a specific legal request has been received and validated. Option C. prioritizing the use of proprietary network management systems that offer advanced monitoring features, assuming they can be adapted for lawful intercept. Option D, designing the network with dedicated lawful intercept interfaces that are provisioned and tested to meet specific regulatory standards for data access and format. The correct answer is D, designing the network with dedicated lawful intercept interfaces that are provisioned and tested to meet specific regulatory standards for data access and format. Explanation: scenario analysis. Implementing LTE networks within a service provider context inherently involves navigating a complex web of regulations governing spectrum usage, network deployment, and data privacy. The challenge lies in ensuring that technical decisions align with these regulatory mandates, which can vary significantly and are subject to change. A service provider must balance the drive for innovation and service expansion with the imperative of compliance, as failure to do so can result in substantial fines, reputational damage, and operational disruptions. This scenario specifically highlights the need to consider the implications of network configuration on lawful intercept capabilities, a critical regulatory requirement in many jurisdictions. Correct approach analysis. The correct approach involves proactively designing and configuring the LTE network to accommodate lawful intercept requirements from the outset. This means understanding the specific mandates of the relevant regulatory body, in this case, assumed to be within the jurisdiction covered by the SPLTE exam, which implies U.S. federal regulations like those from the FCC and CALIA, regarding the ability of law enforcement agencies to access subscriber data and communications. Implementing features like dedicated lawful intercept interfaces, ensuring data is accessible in a standardized format, and maintaining audit trails for access are crucial. This approach represents best professional practice because it embeds compliance into the network architecture, minimizing the risk of costly retrofits or operational failures when lawful intercept requests are made. It demonstrates a commitment to legal and ethical obligations, fostering trust with regulatory bodies and the public. Incorrect approach is analysis. One incorrect approach is to assume that standard network logging is sufficient for lawful intercept. This fails to recognize that regulatory requirements often specify dedicated, secure, and standardized mechanisms for lawful intercept that go beyond general network monitoring. It can lead to delays or inability to fulfill legal requests, resulting in regulatory penalties. Another incorrect approach is to defer lawful intercept implementation until a specific request is received. This reactive stance is highly problematic. It introduces significant risk, as the network may not be designed to support such requests efficiently or securely. The time taken to implement the necessary features under pressure can compromise the effectiveness of law enforcement operations and lead to non-compliance. A third incorrect approach is to prioritize proprietary network management tools over standardized lawful intercept interfaces. While proprietary tools may offer advanced monitoring, they often lack the interoperability and security required by lawful intercept mandates. This can create barriers for law enforcement access and violate regulatory requirements for standardized data formats and access methods. Professional reasoning. Professionals tasked with implementing Cisco service provider mobility LTE networks must adopt a proactive and compliance-first mindset. The decision-making process should involve 1. Identifying all applicable regulatory frameworks and mandates related to network deployment, spectrum usage, and lawful intercept within the relevant jurisdiction. 2. Engaging with legal and compliance teams early in the design and implementation phases to ensure all requirements are understood. 3. Prioritizing network architectures and configurations that inherently support regulatory obligations, such as lawful intercept, rather than treating them as an afterthought. 4. Regularly reviewing and updating network designs and configurations to align with evolving regulatory landscapes. 5. Documenting all compliance-related decisions and implementations for audit and verification purposes. Question 6. The audit findings indicate a recurring pattern of minor service degradations across several LTE cell sites, attributed by the operations team to transient environmental factors, but a formal risk assessment process for these degradations has not been consistently applied. Which of the following actions best addresses this situation in accordance with best practices for implementing Cisco service provider mobility LTE networks? Option A. Conduct a one-time review of the environmental factors and assume that no further action is required unless a major outage occurs. Option B. Classify the reported degradations as acceptable operational noise and focus resources on higher priority network issues. Option C. Initiate a comprehensive risk assessment to identify potential causes, analyze the likelihood and impact of future degradations, and develop proactive mitigation strategies. Option D. Instruct the operations team to document each instance of degradation as it occurs and address them on a case-by-case basis as they arise. The correct answer is C. Initiate a comprehensive risk assessment to identify potential causes, analyze the likelihood and impact of future degradations, and develop proactive mitigation strategies. Explanation: scenario analysis. This scenario presents a professional challenge due to the inherent tension between operational efficiency and regulatory compliance in a critical service provider environment. The audit findings highlight a potential gap in risk assessment processes, which, if unaddressed, could lead to service disruptions, security vulnerabilities, and non-compliance with regulatory mandates governing LTE network operations. The complexity arises from the need to balance the immediate demands of network performance with the long-term imperative of robust risk management, all within the strict confines of the 600-212 SPLTE exam's regulatory framework. Correct approach analysis. The correct approach involves a comprehensive and proactive risk assessment methodology. This entails identifying potential threats to the LTE network's integrity and availability, analyzing their likelihood and impact, and developing appropriate mitigation strategies. This aligns with best professional practices by ensuring that potential risks are systematically evaluated and addressed before they manifest as incidents. From a regulatory perspective, this proactive stance is often mandated or strongly implied by frameworks that require service providers to maintain network resilience and security. It demonstrates due diligence and a commitment to safeguarding critical infrastructure, which is paramount in the telecommunications sector. Incorrect approaches analysis. One incorrect approach would be to dismiss the audit findings as minor or isolated incidents without further investigation. This represents a significant regulatory and ethical failure. It ignores the potential for systemic issues and demonstrates a lack of due diligence in maintaining network security and reliability, which could violate regulations requiring ongoing risk management. Another incorrect approach is to focus solely on immediate technical fixes for reported issues without a broader risk assessment. This is professionally unacceptable because it addresses symptoms rather than root causes, leaving the network vulnerable to similar or different threats in the future. It fails to meet the regulatory expectation of a holistic approach to network risk management. A third incorrect approach is to delegate the entire risk assessment process to a single individual without proper oversight or a defined methodology. This is ethically questionable and professionally unsound, as it concentrates responsibility and potentially overlooks critical perspectives, increasing the likelihood of errors and non-compliance with established risk management standards. Professional reasoning. Professionals in this domain should adopt a structured decision-making process that begins with acknowledging and thoroughly investigating audit findings. This involves engaging relevant stakeholders, utilizing established risk assessment frameworks, aligned with the 600-212 SPLTE exam's implied regulatory context, and prioritizing mitigation efforts based on the assessed risk level. The process should be iterative, with regular reviews and updates to the risk register and mitigation plans. This systematic approach ensures that decisions are data-driven, compliant with regulatory expectations, and contribute to the overall resilience and security of the LTE network. Question 7. Market research demonstrates a growing demand for enhanced mobile broadband services, prompting a service provider to accelerate the deployment of a new LTE network. During the planning phase, several deployment strategies are being considered, which approach best balances the need for rapid market entry with the imperative to manage potential network vulnerabilities and regulatory adherence. Option A. Select the deployment strategy that offers the lowest initial capital expenditure, assuming that cost savings will offset any unforeseen issues. Option B. Conduct a comprehensive risk assessment to identify potential technical, operational, security, and regulatory challenges, and develop mitigation plans before finalizing the deployment strategy. Option C. Prioritize the fastest possible deployment timeline, deferring detailed risk analysis and mitigation planning until after the network is operational. Option D. Adopt the most technologically advanced and feature-rich deployment option, assuming that cutting-edge technology inherently minimizes risks. The correct answer is B. Conduct a comprehensive risk assessment to identify potential technical, operational, security, and regulatory challenges, and develop mitigation plans before finalizing the deployment strategy. Explanation: scenario analysis. Implementing a new LTE network involves significant capital investment and potential disruption to existing services. Key challenge is accurately assessing the risks associated with the chosen deployment strategy, particularly concerning the potential impact on network performance, security, and regulatory compliance. Without a robust risk assessment, a service provider might underestimate costs, overlook critical security vulnerabilities, or fail to meet regulatory obligations, leading to financial penalties, reputational damage, and service degradation. The professional challenge lies in balancing the urgency of market demands with the necessity of thorough due diligence. Correct approach analysis. The correct approach involves a comprehensive risk assessment that systematically identifies, analyzes, and prioritizes potential risks throughout the LTE network implementation lifecycle. This includes evaluating technical risks, e.g., interoperability issues, performance bottlenecks, operational risks, e.g., training gaps, maintenance challenges, security risks, e.g., unauthorized access data breaches, and regulatory risks, e.g., noncompliance with spectrum usage, data privacy laws. By proactively identifying these risks and developing mitigation strategies, the service provider can make informed decisions, allocate resources effectively, and ensure the network is deployed securely and in compliance with all applicable regulations. This aligns with the principles of responsible network deployment and risk management expected of telecommunications operators. Incorrect approach is analysis. Focusing solely on the lowest initial cost without a thorough risk assessment is professionally unacceptable. This approach ignores potential long-term expenses associated with unforeseen technical issues, security breaches, or regulatory fines, represents a failure to exercise due diligence and a disregard for the overall health and security of the network. Prioritizing speed of deployment above all else, without adequately considering the associated risks, can lead to rushed decisions that compromise network stability, security, and compliance. This can result in a network that is prone to failures, vulnerable to attacks, and potentially in violation of regulatory mandates, ultimately harming the service provider and its customers. Implementing only the most advanced, cutting-edge technologies without a proper risk assessment can introduce unforeseen complexities and vulnerabilities. While innovation is important, a responsible approach requires evaluating the maturity of new technologies, their integration challenges, and their potential security implications before widespread deployment. This approach risks introducing instability and security gaps that could have been avoided with a more measured risk evaluation. Professional reasoning. Professionals in this field must adopt a structured and proactive approach to risk management. This involves establishing clear processes for risk identification, assessment, and mitigation at every stage of a project. When faced with competing priorities, such as cost, speed, and technological advancement, the decision-making framework should always incorporate a thorough risk assessment as a foundational element. This ensures that decisions are not only commercially viable, but also technically sound, secure, and compliant with all relevant regulations. The goal is to achieve a balance that maximizes the benefits of the new technology while minimizing potential negative impacts. Question 8. Implementation of a new 5G standalone SA core network for a service provider requires a thorough risk assessment. Which of the following approaches best ensures the security and compliance of the new network infrastructure? Option A. Focusing exclusively on identifying and patching known technical vulnerabilities in the 5G SA core network components, assuming that operational and compliance risks are secondary. Option B. Prioritizing the implementation of the most cost-effective security solutions available, even if they do not fully address all identified high-priority risks. Option C. Conducting a comprehensive risk assessment that identifies potential threats across technical, operational, and compliance domains, analyzes their likelihood and impact, and prioritizes mitigation strategies based on business criticality and regulatory requirements. Option D. Relying on vendor-provided security documentation and industry best practices without conducting an independent, in-depth risk assessment specific to the service provider's deployment. The correct answer is C. Conducting a comprehensive risk assessment that identifies potential threats across technical, operational, and compliance domains, analyzes their likelihood and impact, and prioritizes mitigation strategies based on business criticality and regulatory requirements. Explanation. Scenario analysis. Implementing a new LTE network involves significant risk, particularly concerning the security and privacy of user data and the integrity of the network infrastructure. Service providers must navigate a complex landscape of potential threats, including unauthorized access, data interception, denial of service attacks, and regulatory noncompliance. The challenge lies in proactively identifying, assessing, and mitigating these risks within the constraints of operational efficiency and budget, while adhering to stringent regulatory requirements. A failure in risk assessment can lead to severe consequences, including data breaches, service disruptions, financial penalties, and reputational damage. Correct approach analysis. The correct approach involves a comprehensive, multifaceted risk assessment that systematically identifies potential threats, analyzes their likelihood and impact, and prioritizes mitigation strategies. This includes considering technical vulnerabilities in the LTE core and radio access network, operational risks associated with network management and maintenance, and compliance risks related to data protection regulations. A robust assessment would involve threat modeling, vulnerability scanning, penetration testing, and a review of security policies and procedures. This proactive and structured methodology ensures that risks are understood and managed before they materialize, aligning with the principles of due diligence and responsible network operation. It directly supports the implementation of secure and reliable LTE services, which is a fundamental requirement for service providers. Incorrect approaches analysis, focusing solely on immediate technical vulnerabilities without considering the broader operational and compliance landscape, is an incomplete risk assessment. This approach might overlook risks related to human error, insider threats, or evolving regulatory requirements, leaving the network exposed to unforeseen threats. Prioritizing cost reduction over thorough risk mitigation is a critical failure. While budget is a constraint, compromising on security and risk management to save money can lead to significantly higher costs in the long run due to incident response, recovery, and potential fines. This demonstrates a lack of professional judgment and a disregard for the long-term viability and security of the service. Implementing security measures based on anecdotal evidence or industry buzzwords without a formal risk assessment process is unprofessional and ineffective. This reactive or fashionable approach to security lacks a systematic basis, leading to misallocation of resources and potentially overlooking critical, yet less publicized, risks. It fails to provide a defensible rationale for security investments and leaves the organization vulnerable. Professional reasoning. Professionals should adopt a structured risk management framework, such as ISO 31000 or NIST SP 800-30, adapted for the specific context of LTE network implementation. This framework should guide the process from risk identification and analysis to evaluation, treatment, and monitoring. A key aspect is to involve cross-functional teams, including network engineers, security analysts, legal counsel, and compliance officers, to ensure all facets of risk are considered. Regular reviews and updates to the risk assessment are crucial to adapt to the dynamic threat landscape and evolving regulatory environment. This systematic and comprehensive approach ensures that decisions are informed, defensible, and aligned with the organization's strategic objectives and regulatory obligations. Question 9. Risk assessment procedures indicate that the introduction of a new quality of service, QoS, prioritization feature for emergency services in the LTE network could potentially lead to unintended data leakage if not properly configured. Considering the regulatory framework for the exam's jurisdiction, which of the following actions best addresses this identified risk? Option A. Focus on optimizing the QoS feature for maximum throughput and minimal latency for emergency services, deferring detailed security configuration and testing until after the feature has been widely adopted. Option B. Rely on existing network security measures to safeguard emergency service data, assuming the new QoS feature will not significantly alter the threat landscape or create new vulnerabilities. Option C. Prioritize the immediate deployment of the CO-S feature to ensure emergency services benefit from enhanced performance, and address any potential data leakage issues through post-deployment monitoring and reactive patching. Option D. Implement robust access control mechanisms and encryption protocols for all emergency service data traffic, and conduct thorough pre-deployment testing of the CO-S feature's configuration against defined security policies. The correct answer is D. Implement robust access control mechanisms and encryption protocols for all emergency service data traffic, and conduct thorough pre-deployment testing of the CO-S feature's configuration against defined security policies. Explanation. The scenario presents a common challenge in implementing new mobile network technologies, balancing the need for rapid deployment with robust security and compliance. The professional challenge lies in identifying and mitigating potential risks associated with the introduction of a new LTE feature, specifically its impact on data privacy and network integrity, within the strict regulatory confines of the exam's specified jurisdiction. This requires a proactive and systematic approach to risk management, ensuring that all potential vulnerabilities are addressed before they can be exploited. The correct approach involves a comprehensive risk assessment that prioritizes the identification of threats, analysis of their potential impact, and the development of mitigation strategies. This aligns with best professional practices by embedding security and compliance into the network design and deployment lifecycle. Specifically, it adheres to the principles of data protection and network security mandated by the relevant regulatory framework for the exam's jurisdiction, which emphasizes a duty of care to protect user data and ensure service continuity. An incorrect approach might involve overlooking or downplaying the potential security implications of the new feature, perhaps due to time pressures or a lack of understanding of the regulatory requirements. This could lead to a failure to implement necessary security controls, leaving the network vulnerable to breaches and noncompliance. Another incorrect approach could be to focus solely on technical performance without adequately considering the broader impact on data privacy, which is a critical regulatory concern. Such an approach would be professionally unacceptable, as it demonstrates a disregard for legal obligations and ethical responsibilities. Professionals should employ a structured decision-making process that begins with a thorough understanding of the regulatory landscape and the specific technical details of the implementation. This involves engaging relevant stakeholders, including security teams and legal counsel, to ensure all potential risks are identified and evaluated. The process should then move to prioritizing risks based on their likelihood and impact, followed by the selection and implementation of appropriate mitigation strategies. Continuous monitoring and review are essential to adapt to evolving threats and regulatory changes. Question 10. Governance review demonstrates that while the new LTE network deployment is progressing rapidly, the associated risk assessment activities have been significantly compressed, with a focus on high-level threats only. Which of the following approaches best aligns with professional best practices and regulatory expectations for implementing Cisco Service Provider Mobility LTE Networks, SPLTE? Option A. Treat the risk assessment as a one-time activity completed solely during the initial deployment phase, with no further reassessments planned. Option B. Defer the detailed risk assessment until after the network is fully operational to avoid delaying the initial service launch. Option C. Conduct a comprehensive, phased risk assessment that begins during the design phase and continues throughout deployment and operation, integrating findings into network security and operational procedures. Option D. Perform a superficial risk assessment focusing only on the most obvious threats, assuming that more detailed analysis can be conducted later if issues arise. The correct answer is C. Conduct a comprehensive, phased risk assessment that begins during the design phase and continues throughout deployment and operation, integrating findings into network security and operational procedures. Explanation. Scenario analysis. This scenario presents a professional challenge stemming from the inherent tension between rapid LTE network deployment and the imperative to conduct thorough risk assessments. Service providers are under pressure to launch new services and expand coverage quickly, which can lead to shortcuts in the risk assessment process. The challenge lies in balancing the need for speed with the responsibility to identify, analyze, and mitigate potential security and operational risks that could impact network integrity, customer data, and regulatory compliance. The complexity of LTE networks, with their intricate interdependencies and evolving threat landscape, further amplifies this challenge, demanding a nuanced and proactive approach to risk management. Correct approach analysis. The correct approach emphasizes a systematic and integrated risk assessment process that begins early in the deployment lifecycle and continues throughout. This aligns with best professional practices and regulatory expectations for critical infrastructure. By incorporating risk assessment as a foundational element from the initial planning stages, potential vulnerabilities are identified and addressed before they become embedded in the network architecture. This proactive stance minimizes the cost and effort required for remediation, reduces the likelihood of security breaches or service disruptions, and ensures compliance with relevant telecommunications regulations. It demonstrates a commitment to building a secure and resilient network, safeguarding customer trust and the provider's reputation. This approach is professionally sound as it prioritizes the long-term stability and security of the service, which is a core responsibility of a network operator. Incorrect approaches analysis. One incorrect approach involves deferring the comprehensive risk assessment until after the network has been fully deployed and is operational. This is a significant regulatory and ethical failure. It violates the principle of proactive risk management, which is often implicitly or explicitly required by telecommunications regulations that mandate robust security measures and service continuity. Such a delay means that any identified risks are discovered when they are far more difficult and expensive to mitigate, potentially leading to costly rework, service outages, and reputational damage. It also exposes the network and its users to unnecessary risks during the critical initial operational phase. Another incorrect approach is to conduct a superficial risk assessment that only focuses on obvious, high-level threats without delving into the specific technical configurations and interdependencies of the LTE network. This approach is professionally inadequate and ethically questionable because it fails to meet the due diligence expected of a service provider. Regulations typically require a detailed understanding of the network's attack surface and potential failure points. A superficial assessment can lead to the overlooking of critical vulnerabilities, such as misconfigurations in the Evolved Packet Core (EPC), or security flaws in the radio access network (RAN), leaving the network susceptible to exploitation. This demonstrates a lack of professional rigor and a disregard for the potential harm to customers and the broader telecommunications ecosystem. A third incorrect approach is to treat risk assessment as a one-time activity performed only during the initial deployment. This is a failure to adhere to best practices for ongoing network management and security. The threat landscape is constantly evolving, and new vulnerabilities are discovered regularly. LTE networks are also subject to configuration changes and software updates, which can introduce new risks. Regulatory frameworks often imply or state the need for continuous monitoring and reassessment of risks. Failing to conduct periodic risk assessments means that emerging threats and the risks associated with network evolution are not identified or addressed, leaving the network vulnerable over time. This reactive stance is professionally irresponsible and can lead to significant security incidents and compliance issues. Professional reasoning. Professionals in this field should adopt a risk-based decision-making framework that prioritizes proactive identification, analysis, and mitigation of risks throughout the entire network lifecycle. This involves integrating risk assessment into all phases of network design, deployment, operation, and maintenance. When faced with pressures to accelerate deployment, professionals must advocate for the necessary time and resources to conduct thorough risk assessments, clearly articulating the potential consequences of shortcuts. They should leverage established risk management methodologies and industry best practices, ensuring that assessments are detailed, technically sound, and aligned with regulatory requirements. Continuous learning and staying abreast of evolving threats and vulnerabilities are also crucial components of this professional decision-making process. Question 11. The assessment process reveals that critical voice and data services for enterprise customers are experiencing intermittent degradation in latency and throughput during peak hours, impacting their business operations. The network is configured with standard CO-S policies, but these are not adequately differentiating between critical and non-critical traffic. Considering the regulatory framework for telecommunications service provision within the specified jurisdiction, which of the following approaches best addresses this issue while ensuring compliance? Option A. Disable all CoS mechanisms to allow for a more equitable distribution of available bandwidth across all users and services. Option B. Increase the overall network capacity by upgrading backhaul links and radio access network (RAN) equipment to provide more bandwidth for all traffic types. Option C. Implement a dynamic CoS policy that assigns higher priority and guaranteed bit rates to critical service traffic flows, while managing non-critical traffic within defined aggregate maximum bit rates, ensuring that emergency services, if applicable, receive absolute priority. Option D. Reconfigure CoS policies to prioritize all user data traffic equally, regardless of service type, to ensure fairness. The correct answer is C. Implement a dynamic CoS policy that assigns higher priority and guaranteed bit rates to critical service traffic flows, while managing non-critical traffic within defined aggregate maximum bit rates, ensuring that emergency services, if applicable, receive absolute priority. Explanation. The assessment process reveals a common challenge in LTE network deployment, ensuring consistent quality of service, CoS, for critical services across varying network conditions. This scenario is professionally challenging because it requires a deep understanding of how different CoS mechanisms interact and how to configure them to meet stringent service level agreements, SLAs, without violating regulatory mandates for service availability and fairness. The chosen approach must balance performance optimization with adherence to the regulatory framework governing telecommunications services within the specified jurisdiction. The correct approach represents best professional practice because it directly addresses the root cause of the CoS degradation by implementing a granular CoS strategy that prioritizes critical traffic based on defined service levels. This aligns with the principles of efficient resource allocation and service differentiation, which are often implicitly or explicitly supported by telecommunications regulations that aim to ensure reliable service delivery for all users, especially for emergency or business-critical applications. By focusing on specific CoS parameters like guaranteed bitrate, GBR, and aggregate maximum bitrate, AMBER, for different traffic classes, the solution demonstrates a proactive and technically sound method for maintaining service integrity. An incorrect approach that relies solely on increasing overall network capacity without targeted CoS configuration fails to address the specific issue of traffic prioritization. This can lead to inefficient resource utilization and may violate regulatory expectations for differentiated service delivery, particularly if critical services continue to experience degradation. Another incorrect approach that involves disabling CoS mechanisms entirely is a significant regulatory and ethical failure. It directly contravenes the intent of regulations designed to ensure fair access and reliable service, potentially leading to widespread service disruption and non-compliance with mandated CoS standards. Furthermore, an approach that prioritizes non-critical traffic over essential services, even if technically feasible, represents a severe ethical lapse and a direct violation of regulatory principles that often mandate preferential treatment for emergency or vital communications. Professionals should employ a decision-making framework that begins with a thorough analysis of the observed problem, correlating it with defined SLAs and regulatory requirements. This involves understanding the specific CoS parameters available within the LTE network architecture and how they can be configured to meet service objectives. The process should then involve evaluating potential solutions against these requirements, prioritizing those that offer the most effective and compliant resolution. This includes considering the impact on all user groups and ensuring that no regulatory or ethical boundaries are crossed. Continuous monitoring and validation of the implemented solution against performance metrics and regulatory standards are crucial for sustained compliance and service excellence. Question 12. Investigation of the most effective strategy for a service provider to ensure that the implementation of a new LTE advanced feature designed to enhance user data throughput fully complies with the regulatory framework governing telecommunications operations within its operating jurisdiction, without compromising network stability or user privacy. Option A. Implement the new LTE advanced feature immediately to gain a competitive advantage, assuming that standard LTE protocols inherently meet regulatory requirements. Option B. Conduct a comprehensive technical validation of the new LTE advanced feature against all relevant regulatory standards and guidelines, perform thorough interoperability and performance testing in a controlled lab environment, and secure all necessary regulatory approvals before proceeding with a phased rollout. Option C. Prioritize the rapid deployment of the new LTE advanced feature based on vendor assurances of compliance and market demand, deferring detailed regulatory validation to a post-implementation audit. Option D. Rely on the service provider's existing network compliance certifications, assuming they are sufficient to cover any new LTE advanced features without specific revalidation. The correct answer is B. Conduct a comprehensive technical validation of the new LTE advanced feature against all relevant regulatory standards and guidelines. Perform thorough interoperability and performance testing in a controlled lab environment, and secure all necessary regulatory approvals before proceeding with a phased rollout. Explanation. Scenario analysis. This scenario presents a common challenge in service provider mobility networks, balancing the need for rapid deployment of new services with the imperative to maintain network stability and compliance with evolving regulatory mandates. The pressure to meet market demands and competitive pressures can lead to shortcuts or incomplete assessments, potentially jeopardizing network integrity and user experience. Furthermore, the dynamic nature of LTE technology and its integration with existing infrastructure requires a thorough understanding of interdependencies and potential impacts. Correct approach analysis. The correct approach involves a systematic, risk-based evaluation that prioritizes adherence to the regulatory framework governing LTE network deployment and operation within the specified jurisdiction. This includes a comprehensive review of technical specifications against established standards, thorough testing in a controlled environment to validate performance and security, and a detailed impact assessment on existing network elements and services. Crucially, it necessitates obtaining all required regulatory approvals and ensuring that the deployment plan aligns with the principles of lawful interception, data privacy, and spectrum management as defined by the relevant authorities. This proactive and compliant approach minimizes the risk of service disruptions, security breaches, and regulatory penalties, thereby safeguarding the service provider's reputation and operational continuity. Incorrect approaches analysis. Deploying new LTE features without a thorough validation against the regulatory framework is a significant failure. This bypasses essential checks for compliance with lawful interception requirements, which are critical for national security and law enforcement. It also risks violating data privacy regulations by potentially mishandling user data or failing to implement necessary security controls mandated by law. Implementing new LTE features based solely on vendor recommendations without independent verification against the regulatory framework is also problematic. Vendors may not be fully aware of or prioritize the specific regulatory obligations of the service provider's jurisdiction. This can lead to the adoption of configurations or functionalities that, while technically sound, are not compliant with local laws concerning spectrum usage, network security, or subscriber privacy. Prioritizing speed of deployment over a comprehensive regulatory compliance check is a direct contravention of the governing laws. Regulatory frameworks are established to ensure public safety, fair competition, and the responsible use of telecommunications infrastructure. Ignoring these mandates for the sake of expediency can result in severe legal repercussions, including fines, operational restrictions, and reputational damage. It also undermines the trust placed in the service provider by both users and regulatory bodies. Professional reasoning. Professionals in this field must adopt a risk-aware and compliance-first mindset. The decision-making process should begin with a clear understanding of the applicable regulatory landscape. Before any technical implementation, a thorough assessment of how the proposed changes align with these regulations is paramount. This involves consulting relevant legal and compliance departments, reviewing technical documentation against regulatory requirements, and conducting rigorous testing. When faced with pressure to accelerate deployment, professionals should advocate for a phased approach that allows for regulatory checks at each stage, rather than compromising on compliance. Escalating concerns about potential non-compliance to senior management and legal counsel is a critical step in ensuring responsible decision-making. Question 13. What factors determine the optimal balance between implementing advanced security features for an LTE network and ensuring minimal impact on user experience and network performance, within the scope of regulatory compliance for service providers. Option A. Prioritizing the deployment of the most widely advertised and feature-rich security solutions, regardless of their specific applicability to the LTE network's threat profile or their potential performance overhead. Option B. Focusing solely on reducing operational costs by selecting the least expensive security hardware and software, without a thorough evaluation of their effectiveness or their impact on network throughput. Option C. A comprehensive risk assessment that identifies specific LTE network vulnerabilities, evaluates potential threats, quantifies the impact of security incidents, and aligns security measures with regulatory mandates and service-level objectives. Option D. Implementing security protocols based on historical attack patterns that are no longer prevalent, while neglecting to consider emerging threats and the specific security requirements mandated by the operating region. Correct answer is C. A comprehensive risk assessment that identifies specific LTE network vulnerabilities, evaluates potential threats, quantifies the impact of security incidents, and aligns security measures with regulatory mandates and service-level objectives. Explanation. This scenario presents a professional challenge in balancing the need for robust network security and performance with the operational realities of a service provider environment. The challenge lies in identifying and implementing security measures that are effective against evolving threats without unduly impacting the user experience or the network's ability to deliver services reliably. Careful judgment is required to select security configurations that align with the specific threat landscape and the service provider's risk appetite, all while adhering to relevant regulatory mandates. The correct approach represents best professional practice because it prioritizes a comprehensive, risk-based strategy. This involves understanding the specific vulnerabilities of the LTE network, the potential impact of security breaches, and the regulatory requirements governing data protection and service availability. By focusing on a layered security model that includes robust authentication, encryption, and intrusion detection, the service provider can proactively mitigate risks. Adherence to the regulatory framework, which in the context of the SPLTE exam would implicitly refer to relevant telecommunications and data privacy regulations applicable to the deployment region, e.g., FCC regulations in the U.S. for spectrum use and network security, or GDPR in Europe for data protection, ensures legal compliance and builds customer trust. This approach is proactive, adaptable, and aligned with industry best practices for secure network operations. An incorrect approach that solely focuses on minimizing capital expenditure without a thorough risk assessment would be professionally unacceptable. This failure stems from a disregard for potential security breaches, which could lead to significant financial losses, reputational damage, and regulatory penalties. Such an approach neglects the ethical obligation to protect customer data and ensure service continuity. Another incorrect approach that implements security measures without considering their impact on network performance would also be a failure. This could lead to degraded user experience, increased churn, and potential service level agreement (SLA) violations, which are also subject to regulatory scrutiny and contractual obligations. Furthermore, implementing security measures that are not aligned with the specific threat profile of the LTE network, such as focusing on outdated attack vectors, represents a failure in due diligence and could leave the network vulnerable to current threats. The professional decision-making process for similar situations should involve a structured risk management framework. This includes identifying assets and vulnerabilities, assessing threats and their likelihood, evaluating the potential impact of security incidents, and determining appropriate mitigation strategies. It is crucial to consult relevant regulatory guidelines and industry best practices throughout this process. Regular review and updates to security policies and configurations are also essential to adapt to the evolving threat landscape and technological advancements. Collaboration between network engineering, security operations, and legal/compliance teams is vital to ensure a holistic and effective security posture. Question 14. When evaluating the integration of a new LTE feature that enhances user data throughput, which approach best ensures compliance with service provider operational guidelines and relevant telecommunications regulations for network stability and security? Option A. Deploy the feature to a limited set of high-priority customers first, gathering feedback before a wider release, without formal regulatory review. Option B. Rely on vendor-provided documentation and assume the feature is compliant with all existing regulations without independent verification. Option C. Implement the feature directly into the live network after a brief internal technical review to expedite service availability. Option D. Conduct comprehensive lab testing, pilot deployment in a controlled segment of the live network, and obtain necessary regulatory approvals before full rollout. The correct answer is C. Implement the feature directly into the live network after a brief internal technical review to expedite service availability. Explanation. This scenario presents a common challenge in service provider mobility networks, balancing the need for rapid deployment of new services with the imperative to maintain network stability and compliance with evolving regulatory frameworks. The professional challenge lies in identifying the most effective and compliant method for integrating a new LTE feature without introducing unforeseen risks or violating established operational procedures and regulatory mandates. Careful judgment is required to select an approach that is both technically sound and legally defensible. The correct approach represents best professional practice because it prioritizes a structured, risk-averse, and compliant integration process by adhering to the established change management framework, which includes thorough testing in a controlled environment and obtaining necessary regulatory approvals. The service provider minimizes the likelihood of service disruption, security breaches, or non-compliance. This systematic approach ensures that all potential impacts are assessed, documented, and mitigated before widespread deployment, aligning with the principles of responsible network operation and regulatory adherence. An incorrect approach that bypasses formal testing and regulatory review would represent a significant regulatory and ethical failure. Such an approach demonstrates a disregard for established operational procedures designed to protect network integrity and customer service. It could lead to service outages, data breaches, or other security vulnerabilities, which in turn could result in substantial fines, reputational damage, and legal repercussions for the service provider. Furthermore, deploying features without proper validation could inadvertently violate specific technical standards, service-level agreements mandated by regulatory bodies, leading to non-compliance. Another incorrect approach that focuses solely on speed without considering the regulatory implications would be professionally unacceptable. While agility is important, it cannot come at the expense of compliance. Ignoring regulatory requirements, such as data privacy or spectrum usage rules, can have severe consequences. This approach fails to recognize that regulatory frameworks are in place to ensure fair competition, protect consumers, and maintain the overall stability of the telecommunications ecosystem. The professional decision-making process for similar situations should involve a multifaceted evaluation. First, thoroughly understand the technical requirements and potential impact of the proposed change. Second, consult the relevant regulatory framework and internal policies to identify all compliance obligations. Third, assess the risks associated with different integration strategies, prioritizing those that minimize disruption and ensure compliance. Fourth, engage with all relevant stakeholders, including engineering, operations, legal, and regulatory affairs teams, to ensure a comprehensive review. Finally, document the entire process, including the rationale for the chosen approach and any mitigation strategies implemented. Question 15. System analysis indicates that a new regulatory framework has been introduced, mandating stricter controls on the collection and processing of subscriber location data within LTE networks to enhance user privacy. The service provider must ensure that all network elements involved in location data handling comply with these new requirements by the end of the fiscal quarter. Which of the following approaches best aligns with professional best practices and regulatory compliance for implementing these changes? Option A. Conduct a thorough impact assessment of the new regulations on all location data handling processes within the evolved packet core, EPC, and implement necessary technical and procedural modifications to ensure full compliance before the deadline. Option B. Prioritize the deployment of new revenue-generating services and address the location data privacy regulations only after these services are fully operational and market-tested. Option C. Implement a basic logging mechanism for location data access and assume this fulfills the regulatory requirement for stricter controls, deferring more complex changes to a later operational review. Option D. Rely on existing data anonymization techniques, assuming they are sufficient to meet the new privacy mandates, and only make minor configuration adjustments if explicitly required by the regulatory body. The correct answer is A. Conduct a thorough impact assessment of the new regulations on all location data handling processes within the Evolved Packet Core (EPC), and implement necessary technical and procedural modifications to ensure full compliance before the deadline. Explanation: Scenario analysis. This scenario presents a common challenge in LTE network deployment, balancing the need for rapid service rollout with adherence to evolving regulatory requirements. The professional challenge lies in interpreting and applying potentially ambiguous or newly introduced regulations to a live or near-live network environment. The pressure to meet business objectives, e.g., market share, revenue targets, can create a temptation to prioritize speed over thorough compliance, leading to significant risks. The specific challenge here is the introduction of a new regulatory mandate concerning user data privacy, which directly impacts how subscriber information is handled within the Evolved Packet Core (EPC). Correct approach analysis. The correct approach involves a proactive and systematic integration of the new regulatory requirement into the network's operational and design frameworks. This means not just understanding the letter of the law, but also its spirit and intent, which in this case is to enhance user privacy. Best professional practice dictates a thorough impact assessment of the new regulation on existing network functions, data flows, and security protocols. This includes identifying all points where subscriber data is processed, stored, or transmitted, and determining how the new privacy mandate affects these operations, implementing necessary technical controls, updating configurations, and potentially revising operational procedures to ensure compliance before the regulatory deadline is crucial. This approach demonstrates a commitment to legal and ethical responsibilities, safeguarding both the operator and its subscribers from potential penalties and reputational damage. It aligns with the principle of privacy by design, embedding privacy considerations from the outset of any network change or deployment. Incorrect approaches analysis. One incorrect approach involves assuming that existing data handling practices are sufficient and that the new regulation will not significantly alter operational requirements. This is a failure to conduct due diligence and a direct violation of the regulatory mandate. Ethically, it disregards the stated intent of the regulation to protect user privacy. Legally, it exposes the operator to fines and sanctions for noncompliance. Another incorrect approach is to implement superficial changes that technically address the regulation, but do not fundamentally alter the risk profile of user data. For example, merely adding a disclaimer without changing data access controls or retention policies would be insufficient. This approach is ethically questionable as it creates a false sense of compliance and fails to provide genuine privacy protection. It also carries legal risks, as regulators often look beyond surface-level adherence to the actual impact on user data. A third incorrect approach is to delay implementation until the last possible moment, hoping for clarification or a grace period. While some flexibility might exist, relying on this is professionally risky. It increases the likelihood of rushed, error-prone implementations and can lead to accidental noncompliance if unforeseen issues arise. This approach demonstrates a lack of proactive risk management and can be seen as a disregard for the regulatory authority. Professional reasoning. Professionals in this field must adopt a risk-based, compliance-first mindset. When faced with new regulations, the decision-making process should involve 1. Understanding the regulatory scope and impact, thoroughly research and interpret the new mandate. 2. Conducting a comprehensive impact assessment, analyze how the regulation affects current network architecture, operations, and data handling. 3. Developing a phased implementation plan, outline the technical and procedural changes required with clear timelines and responsibilities. 4. Engaging with stakeholders. Collaborate with legal, security, and operational teams to ensure a holistic approach. 5. Continuous monitoring and validation. Regularly verify that implemented controls are effective and remain compliant. This structured approach ensures that business objectives are pursued responsibly, with a strong foundation of regulatory adherence and ethical conduct. Question 16. Operational review demonstrates that a service provider is planning to implement advanced LTE features that could potentially alter data handling and user session management. To ensure compliance with all applicable regulatory frameworks governing data privacy and network security, Which of the following approaches represents the most professionally sound and compliant method for introducing these new features? Option A. Conduct comprehensive security and privacy impact assessments, followed by a phased deployment with rigorous testing in isolated environments and obtaining necessary regulatory approvals before full activation. Option B. Prioritize the upgrade of network performance and user experience metrics, deferring detailed security and privacy reviews until after the features are fully operational. Option C. Immediately deploy the new LTE features across the entire network to leverage their benefits and address any compliance concerns through post-deployment audits. Option D. Implement the new LTE features on a limited number of user devices as a pilot without formal impact assessments to gauge user reaction and address compliance issues if they arise. The correct answer is A. Conduct comprehensive security and privacy impact assessments, followed by a phased deployment with rigorous testing in isolated environments and obtaining necessary regulatory approvals before full activation. Explanation: scenario analysis. This scenario presents a common challenge in service provider mobility networks, ensuring consistent and compliant user experience across evolving technologies while adhering to strict regulatory mandates. The professional challenge lies in balancing the technical imperative to upgrade and optimize LTE services with the legal and ethical obligation to maintain data privacy and security as defined by relevant regulations. The need for a robust, auditable, and compliant approach to network upgrades is paramount, especially when dealing with sensitive user data. Correct approach analysis. The correct approach involves a phased, risk-assessed deployment of the new LTE features, prioritizing comprehensive security and privacy impact assessments before and during each phase. This aligns with best practices in regulatory compliance, particularly concerning data protection frameworks. By conducting thorough testing in isolated environments and obtaining explicit regulatory approval for any changes impacting data handling or user privacy, the service provider demonstrates due diligence. This proactive stance minimizes the risk of noncompliance, protects user data, and ensures that the network upgrade adheres to the spirit and letter of the law, fostering trust and maintaining operational integrity. This approach is professionally sound, as it embeds compliance into the technical lifecycle. Incorrect approaches analysis. Deploying new LTE features without a formal security and privacy impact assessment before user activation is a significant regulatory and ethical failure. It violates principles of data minimization and privacy by design, potentially exposing user data to unauthorized access or misuse. This approach risks contravening data protection laws by failing to adequately identify and mitigate privacy risks associated with the new features. Implementing the upgrade across the entire network simultaneously without phased testing or pilot programs introduces an unacceptable level of risk. If a compliance issue or security vulnerability arises, it would affect all users, leading to widespread regulatory penalties and reputational damage. This demonstrates a lack of responsible deployment strategy and a disregard for the potential impact on user privacy and data security. Focusing solely on performance metrics and user experience improvements while deferring security and privacy reviews until after deployment is also a critical failure. This reactive approach prioritizes commercial objectives over legal and ethical obligations. It creates a situation where the network may already be non-compliant, necessitating costly and disruptive remediation efforts, and potentially exposing the service provider to legal action and fines for past non-compliance. Professional reasoning. Professionals in this domain must adopt a proactive and risk-aware decision-making process. This involves integrating regulatory compliance and security considerations into the earliest stages of network design and deployment. A structured approach, including thorough impact assessments, phased rollouts, continuous monitoring, and clear documentation, is essential. When faced with technical advancements, the professional's primary responsibility is to ensure that these advancements are implemented in a manner that upholds all legal and ethical obligations, particularly concerning user data privacy and security. This requires a constant evaluation of potential risks against regulatory requirements and the implementation of robust mitigation strategies. Question 17. Quality control measures reveal that a service provider is preparing for a large-scale LTE network rollout in a new geographical region. The deployment team has primarily relied on the default configuration settings provided by the network equipment vendor, assuming these are universally compliant. What is the most critical oversight in this approach regarding regulatory compliance for spectrum usage? Option A. Failing to consider the potential for interference with existing licensed broadcast services. Option B. Assuming vendor default configurations are universally compliant with local spectrum regulations. Option C. Overlooking the need for a detailed site survey to identify potential signal propagation issues. Option D. Prioritizing the implementation of advanced LTE features over basic regulatory adherence. The correct answer is B. Assuming vendor default configurations are universally compliant with local spectrum regulations. Explanation. Scenario analysis. This scenario presents a common challenge in LTE network deployment, where the service provider must balance the need for rapid service rollout with adherence to regulatory requirements for spectrum usage and interference mitigation. The professional challenge lies in interpreting and applying complex technical specifications within the context of evolving regulatory landscapes, ensuring both network performance and compliance. The pressure to launch services quickly can lead to shortcuts, making a thorough understanding of the regulatory framework paramount. Correct approach analysis. The correct approach involves a meticulous review of the specific LTE band regulations applicable to the deployment region, as defined by the relevant national regulatory authority, e.g., FCC in the US, Ofcom in the UK, ECMA in Australia. This includes understanding the permitted power levels, out-of-band emission limits, and any specific channel usage restrictions. Implementing a robust testing and validation process that verifies the network's compliance with these regulations before commercial launch is best professional practice. This proactive approach minimizes the risk of regulatory penalties, service disruptions due to interference, and reputational damage. It demonstrates a commitment to responsible spectrum stewardship, a key ethical and legal obligation for any licensed spectrum user. Incorrect approaches analysis. One incorrect approach is to rely solely on vendor-provided default configurations without independent verification against local regulations. This fails to acknowledge that vendor defaults may not be optimized for or compliant with the specific regulatory environment of the deployment. This can lead to unintentional noncompliance, potentially resulting in fines or forced network adjustments. Another incorrect approach is to assume that compliance in one region automatically translates to compliance in another. Regulatory frameworks for spectrum management are jurisdiction-specific. Deploying a network based on assumptions derived from a different regulatory jurisdiction is a direct violation of the principle of adhering to local laws and can lead to significant legal and operational issues. A third incorrect approach is to prioritize speed of deployment over thorough regulatory validation, intending to address any compliance issues post-launch. This is ethically and legally unsound. Operating a non-compliant network, even temporarily, can cause harmful interference to other licensed services and exposes the operator to severe penalties. It undermines the integrity of the regulatory system and the principle of fair spectrum access for all licensees. Professional reasoning. Professionals in this field must adopt a risk-based approach to network deployment. This involves 1. Identifying all applicable regulatory requirements for the target deployment region. 2. Integrating regulatory compliance checks into the network design and testing phases. 3. Conducting thorough validation using calibrated equipment to confirm adherence to all technical and operational regulations. 4. Establishing a continuous monitoring process to ensure ongoing compliance. 5. Maintaining detailed documentation of all compliance activities and test results. This systematic process ensures that technical objectives are met within the legal and ethical boundaries set by regulatory authorities. Question 18. The audit findings indicate that the lawful intercept (LTE) functionality within the service provider's LTE network is not configured in strict adherence to the applicable U.S. regulatory framework, potentially impacting the ability to comply with law enforcement requests. What is the most appropriate course of action to address this critical noncompliance? Option A. Disable the lawful intercept functionality entirely until a full understanding of the regulatory requirements can be achieved, to avoid any immediate noncompliance issues. Option B. Initiate a comprehensive review of the specific U.S. regulations governing lawful intercept for telecommunications providers. Develop a detailed remediation plan with rollback procedures. Obtain stakeholder approval, and implement the changes during a scheduled maintenance window with thorough post-implementation verification. Option C. Immediately implement a revised LI configuration based on the latest vendor best practices, without extensive pre-deployment testing, to expedite compliance. Option D. Proceed with a configuration change based solely on the vendor's technical documentation, assuming it fully covers all regulatory mandates, and monitor the network for any immediate service degradation. The correct answer is C. Immediately implement a revised LI configuration based on the latest vendor best practices, without extensive pre-deployment testing, to expedite compliance. Explanation. Scenario analysis. This scenario presents a common implementation challenge in LTE networks where a critical security feature, lawful intercept, LI, is found to be non-compliant during an audit. The challenge lies in balancing the immediate need to rectify the non-compliance with the operational impact on a live service provider network. Rushing a fix without proper planning can lead to service disruptions, further security vulnerabilities, or even regulatory penalties. The pressure to resolve the audit finding quickly, coupled with the complexity of LI configurations, which often involve sensitive data handling and strict legal requirements, necessitates a meticulous and well-governed approach. The professional challenge is to ensure the solution is not only technically sound, but also fully compliant with the relevant regulatory framework, specifically the U.S. regulations governing lawful intercept for telecommunications providers. Correct approach analysis. The correct approach involves a phased, risk-mitigated strategy that prioritizes regulatory compliance and operational stability. This begins with a thorough understanding of the specific U.S. regulations, e.g., Communications Assistance for Law Enforcement Act (CALIA), that mandate LI capabilities and their precise implementation requirements. The next step is to develop a detailed remediation plan that outlines the technical changes, testing procedures, and rollback strategies. Crucially, this plan must be reviewed and approved by relevant stakeholders, including legal, compliance, and operations teams, before any changes are made to the live network. Implementing the changes during a scheduled maintenance window, followed by comprehensive post-implementation verification and ongoing monitoring, ensures that the LI functionality is restored correctly and securely without impacting subscriber services. This approach represents best professional practice because it demonstrates due diligence, adherence to legal mandates, and a commitment to operational excellence. It minimizes risk by ensuring that all aspects of the LI implementation are validated against regulatory requirements and network stability. Incorrect approaches analysis. Implementing an immediate, unverified configuration change without a proper rollback plan is a significant regulatory and ethical failure. This approach bypasses essential validation steps, increasing the risk of introducing new vulnerabilities or causing service outages, which could lead to further audit findings and potential legal repercussions for non-compliance with service availability and security standards. Attempting to disable the LI functionality altogether to resolve the audit finding, without first consulting legal and compliance teams and understanding the specific U.S. regulatory obligations for LI, is a direct violation of lawful intercept mandates. This action would likely result in severe legal penalties and a complete breakdown of cooperation with law enforcement agencies, representing a critical ethical and legal failure. Relying solely on vendor documentation for the LI configuration without independent verification against specific U.S. regulatory requirements, and the service provider's operational context is also professionally unacceptable. While vendor documentation is important, it may not encompass all nuances of specific regulatory interpretations or the unique network environment, leading to a misconfigured LI solution that remains non-compliant and potentially insecure. Professional reasoning. Professionals facing such an audit finding must adopt a structured decision-making process. First, thoroughly understand the specific regulatory requirements applicable to the non-compliant feature. In this case, U.S. lawful intercept regulations. Second, conduct a comprehensive impact assessment to understand the technical and operational implications of any proposed solution. Third, develop a detailed remediation plan that includes risk mitigation strategies, testing protocols, and rollback procedures. Fourth, Engage all relevant stakeholders, including legal and compliance departments, for review and approval. Finally, execute the remediation plan methodically, with rigorous verification and ongoing monitoring, ensuring that the solution is both technically sound and fully compliant. This systematic approach ensures that regulatory obligations are met while maintaining network integrity and service quality. Question 19. Strategic planning requires a comprehensive approach to integrating lawful intercept capabilities within a new LTE network deployment to ensure compliance with U.S. regulatory mandates, specifically the Communications Assistance for Law Enforcement Act, CALIA. Considering the pressure to launch services rapidly, which implementation strategy best balances operational efficiency with legal and ethical obligations? Option A. Implement lawful intercept features based on general industry best practices without specific validation against the detailed technical and procedural requirements of CALIA. Option B. Design and deploy the LTE network with lawful intercept functionalities as a core component from the outset, ensuring all equipment and configurations meet CALIA requirements and establishing clear operational procedures for lawful interception. Option C. Prioritize rapid service deployment and address lawful intercept requirements only after the network is operational, using a third-party solution to retroactively integrate the necessary capabilities. Option D. Assume that standard network equipment will inherently support lawful intercept and defer detailed CALIA compliance checks until a specific interception request is received. The correct answer is B. Design and deploy the LTE network with lawful intercept functionalities as a core component from the outset, ensuring all equipment and configurations meet CALIA requirements and establishing clear operational procedures for lawful interception. Explanation. Scenario analysis. This scenario presents a common implementation challenge in LTE networks, balancing the need for rapid service deployment with the stringent regulatory requirements for lawful intercept. Service providers operate under a legal obligation to facilitate lawful interception of communications for authorized government agencies. Failure to comply can result in severe penalties, including fines and license revocation. The challenge lies in integrating lawful intercept capabilities seamlessly into the network architecture, without compromising performance, security, or the user experience, all while adhering to specific, often evolving regulatory mandates. The pressure to launch new services quickly can create a temptation to defer or inadequately address lawful intercept requirements, which is a significant professional risk. Correct approach analysis. The correct approach involves proactively designing and implementing lawful intercept capabilities as an integral part of the network architecture from the initial planning stages. This means selecting network equipment and software that inherently support lawful intercept functionalities, and ensuring that the operational procedures and configurations are compliant with the relevant regulatory framework. For example, in the U.S. context, this would involve adherence to the Communications Assistance for Law Enforcement Act CALIA. This proactive integration ensures that the network is not only compliant, but also resilient and efficient, minimizing the risk of future remediation efforts and potential legal repercussions. It demonstrates a commitment to both service innovation and legal responsibility, which is a hallmark of best professional practice in the telecommunications industry. Incorrect approaches analysis. Implementing lawful intercept capabilities as an afterthought or relying solely on post-deployment solutions is a significant regulatory and ethical failure. This approach risks creating a network that is non-compliant with CALIA, leading to potential legal action and financial penalties. It also introduces security vulnerabilities and performance degradation, as these capabilities are retrofitted, rather than being part of the original design. Furthermore, it demonstrates a lack of foresight and a disregard for the legal obligations of a service provider, which is ethically unsound. Another incorrect approach is to assume that generic lawful intercept solutions will meet specific regulatory requirements without thorough validation. This can lead to a false sense of compliance, where the implemented solution does not actually meet the technical or procedural mandates of CALIA, resulting in non-compliance and potential legal issues. Professional reasoning. Professionals must adopt a risk-based approach to network implementation. This involves identifying all regulatory obligations, including lawful intercept, early in the project lifecycle. The decision-making process should prioritize compliance and security alongside performance and cost. When faced with competing priorities, such as rapid deployment versus compliance, professionals must advocate for solutions that satisfy both. This often requires engaging with regulatory bodies, legal counsel, and equipment vendors to ensure that all requirements are understood and met. A robust change management process should also be in place to ensure that any modifications to the network, including those related to lawful intercept, are properly documented, tested, and approved. Question 20. Operational review demonstrates a consistent degradation in VoLTE LTE call quality and an increase in call drops during peak hours, particularly in densely populated urban areas. Network utilization metrics indicate that while overall capacity is not consistently maxed out, specific resource contention is occurring. The implementation team needs to address this without impacting the overall data throughput for non-voice services significantly. Option A. Focus solely on optimizing the backhaul capacity to the affected cell sites, assuming that radio access is not the primary bottleneck for VoLTE LTE quality. Option B. Disable CO-S mechanisms for all traffic types to simplify network management and allow for maximum resource utilization by any service. Option C. Increase the overall bandwidth allocation for the affected cell sites to alleviate congestion without making specific CO-S adjustments for VoLTE LTE. Option D. Implement a differentiated CO-S strategy that prioritizes VoLTE LTE traffic using appropriate QCIs, ensures dedicated radio bearers, and employs traffic shaping for non-essential data services to manage congestion during peak times. The correct answer is D. Implement a differentiated CO-S strategy that prioritizes VoLTE LTE traffic using appropriate QCIs, ensures dedicated radio bearers, and employs traffic shaping for non-essential data services to manage congestion during peak times. Explanation. Scenario analysis. This scenario presents a common implementation challenge in LTE networks, ensuring consistent and reliable quality of service, CO-S, for critical services, specifically VoLTE LTE, across different network segments and under varying load conditions. The challenge lies in the dynamic nature of radio access and the potential for congestion, which can degrade voice quality and lead to dropped calls. Professionals must balance technical configuration with an understanding of how these configurations impact user experience and adherence to service-level agreements, SLAs, which are often implicitly or explicitly tied to regulatory expectations for service availability and quality. Correct approach analysis. The correct approach involves a multifaceted strategy that prioritizes CO-S for VoLTE LTE traffic through a combination of radio resource management, RRM, and quality of service, CO-S mechanisms. This includes implementing appropriate CO-S class identifiers, QCI, for VoLTE LTE, ensuring sufficient radio bearers are allocated, and employing traffic shaping or policing to manage non-critical traffic. Furthermore, proactive monitoring and dynamic adjustment of these parameters based on real-time network conditions are crucial. This represents best professional practice because it directly addresses the technical requirements for VoLTE LTE while also considering the user experience and the operator's commitment to service delivery, which aligns with the spirit of regulatory frameworks that expect reliable telecommunications services. Incorrect approaches analysis. One incorrect approach would be to solely focus on increasing overall network capacity without specific CO-S differentiation for VoLTE LTE. This is professionally unacceptable because it fails to guarantee the low latency and jitter required for voice calls, potentially leading to degraded service for VoLTE LTE users, while others might benefit from increased capacity. This could be seen as a failure to meet implicit service delivery expectations. Another incorrect approach would be to disable or significantly relax CO-S controls on non-essential data traffic to free up resources. This is professionally unsound as it can lead to unpredictable network behavior, potentially impacting the stability and performance of critical services like VoLTE LTE indirectly through congestion and interference. It also demonstrates a lack of understanding of traffic management principles. A third incorrect approach would be to rely solely on reactive troubleshooting after service degradation is reported. This is professionally deficient because it fails to implement proactive measures to prevent issues. While troubleshooting is necessary, a preventative and optimized CO-S strategy is paramount for maintaining high-quality VoLTE LTE service, aligning with the expectation of a robust and reliable network. Professional reasoning. Professionals should approach such challenges by first understanding the specific requirements of critical services like LTE, including their co-S parameters. This understanding should then be translated into concrete network configurations, prioritizing these services through co-S mechanisms. Continuous monitoring and performance analysis are essential to identify potential issues before they impact users. When issues arise, a systematic troubleshooting process, informed by the network's co-S design, should be employed. Adherence to best practices in network engineering and a commitment to delivering reliable services are key ethical and professional considerations.